All right, so this is for those quiz corrections for quiz 2. So have the sub hand these out, or if you weren't there, I should have ones with your name on them inside my attendance book, and just fill them out and use them to study for, okay? So in number 1 here, it says you're given f of x equals x minus 3 squared minus 4. Now this is vertex form. So we want to write an equation of a line that would result in no real solutions for this system. So remember, a system of equations means I have two equations, they do not cross. A lot of you miss this because this is specific and said an equation of a line. And some of you wrote an equation of a parabola. Okay? So, and then in B, it says support how you know the system will have no real solution. So you could verbally tell me, or you could draw a picture. So like if I draw a picture of this graph, I know it went right 3, down 4, and kind of, I'm just going to, okay, it's going to look like that. So I need some line that won't cross this. Well, I could have drawn one like this. I could have drawn one like this, whichever, okay? Well, here I drew them, so up here I would need to write an equation for it. So let me just undo one of those lines. There's a line, okay? I'm going to just say it has a negative slope, so negative x. We'll say this y-intercept, if this was at negative 4, let's just go down, we'll say it's at negative 8. I don't know. So I just kind of made something up there. That works. Many of you had solutions that worked even if they were quadratics, so I didn't take off all the points. But if you didn't follow directions, you at least lost 2 points there. Okay, so that's what that was looking for. So you had to know what a system of equations was. You had to know what it meant to have no real solution. And you had to know how to write an equation of a line there. All right, and you could have supported either visually or written it out into words. All right, so number 2 gives you a system, and it says solve algebraically. So some of you set this up so you could do elimination. You'd have to rearrange some things because we need the x squared stacked together, the x's stacked together, the constants stacked together, and the y's stacked together. Or you could do it substitution. And I see that since the y equals all of this, I'm just going to substitute it in for y and do that. So I get, if I rewrite that second equation, I get x squared plus 2x plus y, which is all of that top equation. So plus 2x squared plus 4x plus 7, and then back to the bottom equation, and that equals 4. So we have a lot of like terms. I'm going to move this 4 to the other side by subtracting 4, and then collect all my like terms and see what we have. So I have an x squared and 2x squared, so that makes 3x squared. I have a 2x and a 4x, so that makes 6x. And then here were the like terms. If I subtracted, let's see, it looks like I'm going to get a positive 3. And now it equals 0 because I subtracted that 4. Okay, well, I can do something with this. Everything's a multiple of 3, so let's just make it smaller and easier to deal with. So I'm going to divide by 3. And then I end up with x squared plus 2x plus 1. All right, and then we just need to pick what method will we solve for x. So the goal here with a system is we have to find both variables, the x and the y, that satisfies both equations. So we always start with finding x because it's super easy to eliminate the y. And then we find x and we'll plug it back in and find the y. So let's see, I could do complete the square here. I could do quadratic formula, but I also see this is factorable, and factoring is just so much faster. Okay, what times what equals 1 but adds to 2? Well, 1 times 1 is 1. 1 plus 1 is 2. So I really have x plus 1 times x plus 1. That was a perfect square trinomial, which makes it x plus 1 squared equals 0. But since they're the same, I can just say, okay, I'm going to say x plus 1 now equals 0, because remember, you set each part equal to 0 to get our answers because of that zero product property. If two things multiplied together to equal 0, one or both have to be 0. In this case, they both happen to be the same thing. I solve for x, and I'm going to get x as negative 1. So this but we need the rest. Okay, this wasn't just a solve for X kind of problem. This is solving a system. So I need to take it and I'm going to plug it into one of the equations. I'll take the first one because the first equation already is set up for y. So y equals 2 times x squared. Well, I just said x is negative 1 plus 4 times x. So 4 times negative 1 plus 7. So let's see, that's going to simplify to be 2 times 1. So that's 2. 4 times negative 1 is a negative 4. And then I have a plus 7. So let's see, 9 minus 4 would be 5. So I have that my intersection point is this. And you should have only had 1 point because these were the same. If they were different, I would have gotten 2 x's and I would have had to plug each in and find the y's that went with each of them. But this only had the 1 point. So describe what that means about the system. Well, since they only intersect at 1 point, and these are both parabolas, you could have just said they only intersect at 1 point. But these also intersect at the vertex of each. And if you would graph these on your calculator, you would have had to let me erase all that. Sorry, I got a lot going on up there. You would have had to solve this bottom one for y, and then you could have plugged it in your calculator, plugged the top one in, and just looked to compare and see. But again, this said algebraically, so you had to solve it algebraically, but you can always use your calculator to check. And you see that the intersection was only at the vertex of each. One of them was aimed down, one of them was aimed up, and it was like that. Boom, right here. Okay, I did accept the answer if you said it only intersects in one place. Okay, so we just want to write an equality for this solution, okay? Now, it is shaded in here. The vertex was right here. It is shaded above. So I know no matter what, it was a greater than y. Okay, because it's above the vertex. Y gets bigger going up. Well, then I also see that this is dashed. Well, that tells me it does not equal. I can't put that underline underneath there. So this has to be in your problem. You missed a point if you said equals or less than. That's not correct. All right. So now let's look at the rest and actually get the equation of a parabola here. All right. So here's my vertex. I can see that it goes to the right 3. So I'm going to have an x minus 3 squared. It went down, let's see, 8. So I have the minus 8. If this is all you put, you did not get full credit because remember those points that we memorized? We had that 1, 1, 2, 4, 3, 9. If I go right 1, do I go up 1? Well, right 1 is over here, but I went up 2 units. So I needed to figure out what did I multiply this by to get to 2. Well, I multiplied by 2. So you had to have a number 2 right there. Okay, so this was the complete correct answer for number 3. All right, come down here. Solve this system. Now I told you when you have inequalities, there's no equal signs here. This is inequalities. You had to graph them. So the only reason you have all this space here is if you need to do some work to be able to graph for your parabola. All right, so let's just start with this top one here. I'm doing this one in blue. All right, it is in standard form, so you could have used complete the square to change it to vertex form, or we have to find its vertex. So let's just do it the old school way, the way we learned it first. I want to find the b, I want to find the x first, so let's do that. So I get negative 4 over 2 times 1/2, so that gives me a 4 over 1. So I get x is 4. Then we find the y, and yes, I do use the equal sign with the y, even though this had a less than symbol. But I have 1/2 x squared, so 4 squared minus 4 times 4 plus 7. And we have to see what that equals. All right, so I end up with y is negative 1. So I know x is 4, y is negative 1, so that means my vertex is 4, negative 1. So if I plot that, if I get rid of these extra lines here, 4, negative 1, it's right here. Now, this has an a of 1/2, so those points that we memorize, 1, 1, 2, 4, 3, 9, I need to multiply this, the y values, by 1/2. So this becomes 1/2, this became 2, this became 4.5. All right, so I go right 1 up 1/2 and left 1 up 1/2. I go right 2 up 2, left 2 up 2, right 3 up 4.5, left 3 up 4.5. Okay, I'm going to call that enough points. And then I look, this one, let me erase that part, okay? Because of this symbol, I know that it's a dashed parabola because it does not equal, so I can go ahead and fill that in. It has to be dashed. And I know it's shaded below because it's less than. So I'm going to do a very light shading because I will probably have to erase some. So I know it's shaded down there. Now let's graph the other one. I'll do it in green here. This one already gives me the vertex. I know my vertex here is going to be a 6, 3. So I go over 6, 1, 2, 3, 4, 5, 6, up 3. I get a point. The points that we memorized for that one, 1, 1, 2, 4, 3, 9. A here is negative, so I had to multiply the y values by negative 1. So I'm just going to change them there, make them negative. So from my vertex, I go right 1, down 1, since it's a minus 1. Then I go down 4, and I go down 9. Now this one, let's look at our symbol. It's equal to, so I know it's solid, not dashed. It is less than, so it is shaded below. All right, so it's solid. Let's get my parabola on there. Not dashed. But it too is shaded below. Now, I can only shade where they're both shaded. Notice neither one, well, the green one would be shaded in here, but the blue one is not. So my shading is not in there. All of my shading is here. And it goes down forever. So all of this other shading I had needs to go away. There should be no shading in between that region that's trapped between the parabolas. It was only here. The A has this as the solution, okay? The work over in the blank spot was just whatever you needed to do to be able to graph those parabolas correctly, dashed, solid, shaded in the right spot. All right, now B says your friend is adamant that 6, 1 is part of the solution set, and you needed to explain why he was wrong. Well, if you graphed wrong, I had to look at your graph and your explanation and determine. But if you graphed correctly, you would have had, okay, 6, 1, 1, 2, 3, 4, 5, 6, 1 is this point right there. That point is on the blue parabola that is dashed. And it's on the edge of the boundary of the shade. And you would have to say, it is not, whoa, I don't know why it's not letting me write, not a solution because a dashed parabola, or you could talk about the symbol up above that it has, the less than, parabola does not, or I'm sorry, whoops, let's see. I got to change my, so it's not a solution because a dashed parabola does, I don't know why I can't write, does not include points on the parabola itself or something like that, on parabola. Or you could have said something like, I know that doesn't make a whole lot of sense. So you could have said this less than symbol means it cannot equal or something. I mean, your wording in your words, but I looked for that, the meaning of those. All right, so that was the quiz. All right, so make those corrections on your quiz. Use it to study from so you are ready for retakes next week.